Hello and welcome to this episode. I've updated the repo. This one doesn't show. And you can look back at old versions. I made a commit that is called part 5 debugging, which is an update to the repo. As far as I know, you can download old repos, right? Let me see. Let me just check this out. If this doesn't contain our debugging, yeah, you can use the GitHub system to access old versions of the code in between episodes. The latest repo is commit is up to date. Yeah. Okay. In this episode here, we will start messing around with something called a command queue. And a command list, since we need at least a command queue to set up our so-called swap chain, which will handle when we want to render stuff to the actual screen. The way I have done it so far has been somewhat different every time. Since we are not creating a design here that is supposed to be easily multi-threaded or handle special case command queue stuff as for now, I won't be doing anything too complicated. Yeah, so you can always develop more advanced components if you want that. We will do a wrapper for the command queue as well. We will only use one type of command queue, which is the, I think it's called the graphics command queue. Let me see. We have the compute command queue and we have the copy command queue, but no, it's called command queue direct, I think. Blah, blah, blah. Lots of examples here. Or rather, not lots, but some examples. Anyway, we will do commands as a subfolder here, and we will create a new wrapper class that will be our D12 command queue. And the command queue is, as you'd expect, something that simply queues up commands. If you're used to working in DirectX 11, even though I have no experience doing that, I suspect that that you don't know the command queue very well, since it's part of the API that got more explicit in DirectX 12. Excuse me. I just need to check some stuff here in terms of the stream setup. Yeah, okay, everything's fine. And we will, as per always, of course, include our com pointer here. Let me just swap this. And we will store an interface to the 3D12 command queue inside of this, we will allow our application to create an empty command queue by using the default constructor. This will be a direct type command queue wrapper. Yeah, the command queue itself will store a so-called fence, which is a synchronization object, probably without me being certain, related to the synchronization component that you find in in Vulkan, which is called semaphores. Each command queue will have a fence value that is updated internally and stored on the command queue interface, or rather, by referencing a fence, the actual fence value gets updated internally in the API whenever the command queue has done something up to the point of a certain fence point. Let me show. I will show you that more in detail what that means, but it's basically a synchronization object here where you use that to, let's do this, and let's actually do it in 64 bits, where you kind of like, how should I phrase it? Now I lost my train of thought, but anyway, defense is something that handles synchronization points on the command queue. Whenever the command queue is done with a set of command list recordings, the command queue will signal the fence and set it to a certain value. You can always query the fence to get the latest completed value, which means that you can always ask the fence how far is the connected command queue to being done in terms of work submissions. But it will probably make more sense whenever we get an example up and running. So we would like some inline functions here where we return a uint 64 and we should be able to ask our command queue whether for a get current fence value. I would like to underscore it to make certain that we don't confuse this function with something that is on the actual command queue interface. You could maybe add a W here. Maybe you want to preface it with a W for the wrapper. Yeah, maybe that's more obvious. Or maybe an M for the member value. Usually I don't preface functions that clearly, but this might end up confusing ourselves down the line. We simply return the current fence value. We would also like to be able to get a fence pointer to our underlying fence. In case we want to query the fence directly about something. All right, we will return to the command queue in a short while because we're not done with this command queue here. Let me see. Let me just close some of this stuff. We actually don't need the device. We could maybe use the helpers. We don't need the application for now, but we would like our render API to have a command queue allocated that it can use to record commands. So let's do a D12 command queue, which we will store on the render API. And we, of course, want a way to initialize our command queue here. And I know from previous experience that it will take a device here, since you will call the initialization of it on the actual device. The way that we will create or initialize our command queue is to create the resources needed, which means the queue itself and the fence. And if you're ever in doubt how to create anything in DirectX 12, simply just Google create whatever component and then DirectX 12. As you can see on the interface for the device in DirectX 12, there's a command called command queue. It would like our old IID PPV macro in terms of where should I store the pointer to the actual underlying interface, but it would also like a command queue description. And we will need to fill out that. So description. And we should always, if it allows us to, initialize it as 0. Some people might be asking, well, why aren't you using const and so forth in your method declarations? Well, sometimes the DirectX API prefers to be able to change different pointers. So that means that we can't simply pass in more pass in constant values. All right, but so we want to fill out the structure. The first one is the type. Let's see which kind of command queue will we use on this, or rather command list will we use on this command queue. As you can see, there are several types. The direct, a command buffer that the GPU can execute. It doesn't inherit any GPU state. The bundles inherit some GPU state. It's just a bundle of commands. I rarely use it, at least for now. And we can do the compute command lists. That is for asynchronous compute, or yeah, for instance, some machine learning algorithms where you don't need the graphics output. There's a copy command list where you can copy information over the PCI lane from the CPU to the GPU, or for that matter, the other way around. But yeah. And there are some video decoding and processing command list types. We will use the direct since it's pertaining to commands that the GPU can execute. Next, we will specify our priority. For this application here, we want the highest priority. Let's see. Global real time sounds great. Well, okay, maybe we just want high. I haven't tested the excuse me. I seem to be catching a cough, which has been building most of the day. Well, next we specify the flags. We don't want any flags. And lastly, we set a so-called node mask. This pertains to if we do SLI related to the dual GPUs setup. I won't support this, but know that if you want to support SLI, which is, as far as I know, not that common anymore, you would need to mess around with the node masks. I can't really help you in terms of that. I think that's a more advanced topic. All right, so now we have our description, and we can simply call our YouTube evaluate each result, and we can ask our device here to create a command queue for us. We will pass in our reference to our description here, and we will pass in our IID PPV args here, and we will of course allow it to store it in our com pointer on this wrapper here. Error creating command queue. And next we want to create a fence. Well, create fence DirectX 12. Well, wouldn't you know, it's also on the device. We want to set an initial value and then some flags. You can do cross adapter sharing. Well, it's not shared, so we will set no flags. We will of course do the YouTube evaluate each result here on the call to create the fence. We will set it to 0, and we will set the flags to 0. None is 0. And then we will do IID PPV args and store our fence here on our fence address. And we want to pass out a error creating the fence if this doesn't succeed. Okay, what does it want? Fence flags, okay, it wants the actual flag here. It's an enum. Okay. I'm sorry. I could of course cast it, but yeah, I already done or started up doing the CmdQueue wrapper here. So that follows I just talked a bit about that. But let me see. I can maybe do a quick summation on that. Let's see. So the type is pertaining to what kind of command list you expect to commit to this kind of queue here. You will use different queues for different types of command lists. You can do command lists that only handle copying of data from the CPU side to the GPU or the other way around. You could do command lists that only do so-called compute operations on the GPU. And there are limitations to what each command list can do. We might, when we do the command list wrapper, actually see a specification on the different types of command lists. But yeah, you can do asynchronous copy steps while working on, for instance, a direct type queue in meanwhile. So yeah, there are different ways of doing multiple things kinda at once, as long as you make sure that everything is synchronized. But for our use case, we will just use a single command queue that can do all our graphics calls. In my own project, I do two command queues right now, and I'll probably implement a third when we do more advanced shader stuff. You also get to set the individual command queue priority. For something like direct, you would prefer something that is high of priority since it will be your main command queue that is supposed to handle most of the heavy lifting, since it can do a lot of different graphics calls through a direct command list. So yeah, you definitely would want a high priority on that. This is direct command queue. Yeah, you could do a copy command queue. It's only for the initialization, and it's just a wrapper. So a lot of the things that we do are kind of like overall wrappers that make our lives a bit easier. Okay, so for now we are done, excuse me, with this part of the command queue. Oh, wait a minute. No, we're not. Because this command queue here actually has allocated resources on itself, whenever we destroy it, we would have to make sure that the resource pointers are reset appropriately. So if we don't do that, we will get a warning from the DXGI debug layer. Let's do a internal function, or rather a public function here that is called release, because we might want to reset the state of the command queue for some reason. Suppose you implemented that you can specify the actual type of the command queue when you initialize it. You might want to reset it and initialize it as something else. Either way, we need to check if our allocated fence, or rather stored fence, actually is allocated, and then we need to reset that pointer so that it decreases the reference count. Then when you destroy your command queue, you of course call release. Let's just initialize here the command queue. Command queue initialize, and we would like our device here. For instance, if I disable this, when we close our application, as you might see down here, let's see, we have several warnings. We have a problem that we can't dereference our device. That might be because we have both a command queue and a fence that actually references our device. So even though we might call the reset on the pointer itself, it's still referenced by our other objects. So this is the power of the DXGI debug layer. It tells us, hey, you forgot to release these things. And we will also, of course, check if this has a pointer set, and then we can call the reset here. Okay, so now we should have no problem when we close the application. Well, oh, wait a minute, this goes out of scope a bit too late. We want to manually actually call release here on our command queue. And we would probably like to do it in the reverse order in terms of initialization. Okay, there we go. Well, we still do end up in a situation where maybe we also need to be able to, maybe this doesn't go out of scope before our application. So maybe we want a release function here where we move this and call release here instead. And then inside our application, whoops, on destruction, we want to call renderer release. And then we want to, excuse me, post how many things we forgot to release. Okay, now we're good. Great stuff. Yeah. So this shows you how the life cycle of different objects / classes in C++ are handled in contrast to the manual handling of reference counting and object lifetimes in terms of the DirectX API. All right. So that is it for our command queue. Well, the destructor does execute, but since we are reporting the live objects when we try to, no, it's a matter of when things get called. So the destruction of, oh, maybe you're lagging or a bit behind me, but yeah, it's related to when the actual classes get deallocated and the destructor gets called in comparison to the scoped pointers. So whenever we call this debug layer here, we haven't destroyed our actual render API because this class hasn't been destroyed. No problem. Anyway, this now works. So we will, for every object that has a set of underlying com pointers, which will increase reference counts to different objects externally, we will make sure to implement a release function. No, I'm not done with the command queue, but I've initialized it and created it. So that's a step, but right now we can't do anything. We only have a command queue, and we would like a command list as well to couple with that command queue. And we will also create a wrapper for that. And we will also create methods that link these things together. So we will do a namespace here again, as per usual. Let's see. And a command list is, as you would expect from our experiences so far with something that something that is called a list. It is, of course, a list. What is it a list of? It's a list of commands. Wouldn't you know? That's awesome. Anyway, we will create a default constructor. We will create a initialize function. As we're trying to do good practice, we will create a release function. And we will, of course, make a destructor that will call the release function whenever we need to. And the thing about command lists is that they are kind of like an interface that needs some kind of buffer. So if we create a command list here, we have to specify the node mask that is for SLI, so it will be 0 and out of interest for us. We will create the type, which we saw during a bit about in our command queue wrapper. We will also need something called a command allocator. And this is actually just a buffer. As you can see, it represents the allocations of storage for graphics processing units and their commands. So imagine this being a vector of commands that the command list can use to store whatever information it would want. It can have several adapters, but it can only use one at a time. You can never deallocate a allocator before the command queue has executed every command on the command list and thereby in the actual command allocator. You can also set a default pipeline state. We won't be doing that. Right now, we will return to pipeline states and do them manually later on. So yeah, let's create a wrapper for this. We know that since we will be calling our device here to create our command list, we know that we would need a pointer to our device. Let's see, I missed a capital D here. We know that we also want a command list allocator or command allocator. So let's just store it in our wrapper, because it will we will only do a single allocator per command list in this implementation. Excuse me. So we will store a command list allocator. We will create our initialize method here. Maybe we should just make Visual Studio declare some and define some function outline here. Yeah, a command allocator is just a buffer. It's just internal storage. It also means that if you keep on recording commands, you might end up in a situation where you have a GPU/CPU related memory leak. Usually memory leaks are seldom in C++, but I've actually experienced a command allocator that had a memory leak. So Visual Studio will show you increasing memory usage in that use case, in that situation, so you can use your internal monitoring in terms of detecting that. But yeah, it's basically a buffer. So of course it can increase in size, and it needs to be managed. All right. We promised ourselves that we would call release, and when we call release, if we have a valid pointer, we will call, let's see, reset. And since we also did an allocator here, if it has a valid pointer to an underlying interface, we would also like to reset that. Excuse me, can't really help it. Anyway, we promised our command queue here that we will only use direct command lists. It doesn't matter, because we actually want to be able to use every graphics call. Yeah, exactly. It's just a self-increasing buffer that is used to store the commands assigned to the command list. And when you submit the command list, as we will see later, to the command queue, you would have to manage that buffer when you are done doing whatever commands you need to do on the command queue, and the fence value reaches a certain point. You can reset the allocator and reopen the command list. But we will get into that later on. Right now we are only doing some wrappers and initializations. We're not doing actually any work yet. So let's do a YouTube thing here. Let's see. We saw that our create command list method would like a pointer to a command allocator. So that means that we need to create the command allocator first. And for that, we just need to specify the type of the command list, which is direct here. So we will do that. YouTube evaluate H result. And we will use our device here. If I can spell it correctly. Create command allocator. And we need a direct type. And then we will just store it in our COM pointer here on this wrapper. Allocator, let's see, get address off. And we want to error creating command allocator. And there's that. And we do another YouTube evaluate H result. And then we call our device create command list. And we don't use a node mask since that pertains to SLI, which we don't use. And we want a pointer to our allocator. Isn't it great that we actually decided to do that first? And then a null pointer because we don't have a specific pipeline state set at initialization time here. We might have, you might have in your application, but at least we do not have it in this application. All right, let's do that. Sorry, I missed the buttons here. So now we initialize our command list. And again, we're just doing wrappers that will make our life easier and this area a bit less cluttered. You could do everything more explicitly if you wanted to. You could do it all in the same function. Yeah, you could basically do whatever you want. I like to create wrappers. I know if we were doing it more C style, we wouldn't be able to do that. Maybe that would be a fun project to do everything in C instead of C++, but yeah, since it's what I'm most familiar with. We do it like this. Let's see. And we, of course, need to pass it our device here. And let's see, does everything compile? Everything compiles. Did we get any errors? We do not release our objects correctly. It complains that we didn't remember to call release on the render API, which is absolutely true. There's no way to hide from the DXGI debug layer. Is it satisfied now? It seems like it's satisfied. Great stuff. So this is our basic wrappers. We will return to these wrappers in the future, since we will be needing to couple them. Right now we haven't any work to do, so it wouldn't make sense to give an example right now. DirectX 12 requires some setup in terms of wrappers and different methodology to be in place to be able to do anything. This means that I will be ending this video here. The stream will continue and I'll do the next step in the next part of the stream and the video series. We have a question here in terms of what I've done. It's basically explained here during our initialization step. We enable the debug layer. We create a factory. We use that factory to get an adapter. We just output some stuff here. Let's see, we could scope this so that it's obvious that this is not related to the actual initialization. Debugging console output for debugging. Then we in debugging output. Then we initialize our device using our adapter that we fetched. We set a name for our device. As you saw during the DXGI stuff, we use the name main virtual device for our current device, and we initialize a command queue with its fence, and we initialize a command list with its command allocator. So this is more initialization. We're not done, and we will probably spend several videos getting done. Next, we will do the swap chain setup, which means that we will actually have some sort of output to our screen within the next video. But in order to set up our swap chain, we needed a command queue, and we will explain more why in the next video. But I'll end the recording here and continue on in the next video segment. All right. If you find anything helpful, inspirational, entertaining, feel free to comment, like, or subscribe, or even support the channel. If you got interested in game development, feel free to tune in during my other live stream here on the channel. All right. See you in the next one.